Hello, my dear students, good afternoon. Now I'll continue quantum numbers in our new session. So, previously we discussed two quantum numbers. One is principal quantum number and one more azimuthal quantum number. So, in this principal quantum number, azimuthal quantum number, what I was given, I'll explain for a few minutes. That's why I written before, because it's like a small recap. So principal quantum number explained by Niels Bohr and explained about energy and size of orbit, and it represent with a small n, and n takes the values 1, 2, 3, 4, 5 and so on, and represent with and given those shells with K, L, M and O. Okay, shell number is 1, 2, 3, 4, and shell we called as, first shell we called as K shell, second shell we called as L shell, and third shell we called as M shell, like that, alphabets from K, L, M and O, P. Okay, number of electrons present in a shell or orbit, both are same actually, don't get confused. 2n square formula, number of electrons present in a shell, 2n square. Number of degenerating orbitals present in a shell or orbit, n square. What is n? This quantum number, principal quantum number, and n is the shell number actually. In K shell, how many electrons are there? Okay, K shell, okay, 1 square. How many electrons? 2 into 1 square. 2 electrons are present in K shell, like that. Okay, in n shell, how many electrons are there? Means, okay, n shell means n value, small n value 4. So 2 into 4 square. Like that, number of electrons you can have, as well as degenerating orbitals. So I was given the difference between shell and subshell, and subshells consist of degenerating orbitals actually. Building, floor consists of rooms. Building is a shell. Okay, and then floor is the subshell actually, SPDF. I was given a SPDF on the subshells. In subshells again they will classify as small rooms, means where electron exactly present. Okay, so that is about the subshell and degenerating orbitals. And azimuthal quantum number L represent with a small n, and L is 0, S subshell, L if 1, P subshell, L if 2, D subshell, L if 3, F subshell. How we will say the total number of L values in a particular possible shell? Okay, means from 0 to n minus 1. This also clearly I was given. Suppose in K shell, how many L values are there? Means from 0 to K shell. No? K shell means L value is 1 or not. So 0 to 1 minus 1. That is L value is just 0. Getting total how many? 1 value. But what is that value? Means 0. That is the difference. Total L values for K shell means 1. What is the L value for K shell? Means 0. Why 0? 0 to 1 minus 1. Because K shell I said. Suppose K shell. K shell means N value is 1. So 1 minus 1, 0. So what is the L value in K shell? Means 0. How many L values? Means 1. That is the difference. And L is 0, S subshell, L if 1, P subshell, L if 2, D subshell, L if 3, F subshell, like that. And L shell have how many L values? Starts from 0 to 2 minus 1. L shell I told na, 0 to 2 minus 1 means 0 comma 1. I told na, starts from 0, ends with n minus 1, means one value less than shell number. If the shell number is 4, L values are starts from 0, 1, 2, 3, because n value I told 4. Got it? So what are those subshells also I was given? 0 means S subshell, no? So in K shell, okay, K shell consists of only one S subshell I told you. L shell means what I told you, actually no need of anything. This n is equals to 1 K shell, n is equals to 2 L shell, n is equals to 2 L shell or not? n is equals to 2. L shell or not? L shell means okay 2, 2, 2. Okay. Every shell starts with S subshell, 2S and 2P. Every shell consists of new subshell, that is 2P here. Is there any P in first shell? No. Now n is equals to 3. N is equals to 3 means what? Shell, KLM. Now 3, 3, 3. Because M shell means n value 3, 0, 1, 2. So 3S, 3P, 3D. 3D is new here. Because 0, 1 and 2. 0 means S subshell, 1 means P subshell, 2 means D subshell. Why I used 3? This 3 we are using to say this S subshell belongs to third shell. This 3S means what is the meaning? This 3S, this S subshell belongs to third shell, like that. Okay. So like that I was given. Getting what I am saying? So one small thing here, n value and L value can never be same. Getting what I am saying? I repeat, n value and L value can never be same for a particular subshell. This is very, very important. Note it down, everyone. Okay. So for if I give a quantum number n is equals to 3, L is equals to 3, is it possible for a subshell? Never. Because I told n if 3, L values are from 0 to n minus 1. One value less we have to consider. Getting what I am saying? So any less than 3, any number is correct. 0 correct, 1 correct, 2 correct. But if n is 3, L is 3 is wrong. Getting what I am saying? So this is very, very important thing. So what I said, n value and L value can never be same. N means small n. Okay. L means azimuthal quantum number. Both can never be same. Got it? So next is shapes of suborbitals or subshells given. What given? This azimuthal quantum number. Explained what shapes of subshells and or else suborbits was given. Okay. Next, how many number of degenerating orbitals present in a subshell? 2L plus 1. Number of electrons present in a subshell, I told that is 4L plus 2 formula. Do you remember? So till here I was explained previously, so I was repeated, so I am not saying please revise that class again. So if you listen this class properly, you can understand. Have a screenshot, and why I am saying all points at one place you will have. Okay. So now I will start third quantum number, that is magnetic quantum number. What quantum number? Magnetic quantum number. Okay. So previously I was explained I think 2 quantum numbers, and now I'll explain third one, that is magnetic quantum number. So what magnetic quantum number explains? Listen everyone, magnetic quantum number explains orientation of orbital, means in what direction that particular orbital is present, we can understand. So our next third one is magnetic quantum number. It represents with a small m actually. So magnetic quantum number given by Mr. Landay actually. He is the scientist who given this magnetic quantum number. Scientist name I written, and it represent with what? This quantum number represent with small m. Represent with small m, and this magnetic quantum number explained about orientation of orbital or atomic orbital. What orbital? That is called degenerating orbital. What is the meaning of orientation? Orientation means a direction. Okay. So how many orientations are there? we will discuss here. Understanding? So here it's very important for us. So it explained about what? Orientation of degenerating orbital, or few people will say atomic orbital, or simply few people will say it explained, it means magnetic quantum number, explained about orientation of orbital. Getting what I'm saying? And I told you, do you remember or not? S, P, D, F, if you see, this S has 1 and P has 3, T has 5, F has 7. These are the degenerating orbitals. Am I told odd numbers like that? So, those odd numbers, suppose P has 3 orientations. That means, so P has 3 degenerating orbitals. P subshell has 3 degenerating orbitals. 3 degenerating orbitals orientations are Px, Py and Pz. That means orientation of orbital is nothing but electron direction it says. What is orbital? Orbital gives 95% probability of finding electron. Means maximum probability of finding electron is orbital. Means Px means electron present in P subshell in x-axis. It means on x-axis. Electron present in P subshell on y-axis. Electron present in P subshell on z-axis. That means direction we are learning or not here? Yes. That orientation was explained in this magnetic quantum number. So given by Lande, represented with a small m, and explained about orientation of degenerating orbitals, and m takes the values. M values are from minus L to plus L. This also gives number of orientations for a particular subshell, which is equal to 2L plus 1. What are the orientations? Means from minus L to plus L, that given by m value. M values gives what? What are the orientations? What are the orientations? What are the orientations can be understand from minus L to plus L. Okay. Number of orientations, how many for a particular subshell? Simply 2L plus 1. This is nothing but odd number, I told you. Odd number. Number of orientations for S, one orientation. For P, 3. For D, 5. For F, 7 orientations. Odd numbers I told you for subshells. Those odd numbers only number of orientations for a particular subshell. What is the orientations understood? Direction of electron. What is orbital meaning exactly understanding? Electron is revolving around the nucleus in a circular orbits. So electron probability we are giving by using these subshells as well as degenerating orbitals. So here you have to remember most important thing, the total m values for any particular subshell. Total m values for any particular subshell means from minus L to plus L. Interesting thing is, first two quantum numbers are related. Now, second and third quantum numbers are related. So, shells consist of subshells. Now, subshells consist of degenerating orbitals. No? So, these degenerating orbitals we will relate with whom? Subshells. Means, azimuthal quantum number we will relate with magnetic quantum number. Shells consist of subshells. So, principal quantum number we are relating with the azimuthal quantum number. Understanding clearly? So, these are very important. So, total number of orientations for a particular subshell, you have 2L plus 1 and the m values are from minus L to plus L. Please note it down all these things. The total number of orientations. If you have not written, write down. Total number of orientations for a subshell is 2l plus 1. That is odd numbers you can remember simply. That's it. Okay. So now I'll tell you about what are the orientations for individual subshells. So I'll talk about S subshell and P subshell and D subshell and F subshell like that. Okay. For S, any S, sir, whether this is 1S or 2S, any S, the L value is 0. I told you already. For P, L value is 1. For D, L value is 2. For F subshell, what I am writing here? Subshell I am writing here. Okay, for subshell I am writing L value here. Now here what is the L value? L value is 3. So now M values. M values means I told you that minus L2 plus L. Now afterwards you have, what is that, you know? What are the orientations? Number of orientations, sorry. What are the orientations means minus L2 plus L. Number of orientations. Yeah. Okay. So what I am writing? Listen carefully. L is 0. So what are the M values? So minus 0 to plus 0. So M values only 0 here. No need to write minus 0 to plus 0. Minus 0 exists. So 0, that's it. So L is 0. Then M values minus L to plus L. Number of orientations, how many? I was given formula, that is 2L plus 1. That is one orientation. That means for any S subshell, one orientation we represent with one box. You please remember, S subshell represent with one dabba, one box. Okay. So like that. Now P, L value 1. So what are the M values? Minus 1, 0 and plus 1. Few people, sir, minus 1 plus 1, sir. Or sir, not end here. 2 means between also will come. Got it? So what are the M values? Means minus L2 plus L means minus 1, 0 and plus 1. Total orientations, how many? Here total orientations, how many? That means 2 into 1 plus 1, that is 3 orientations. How many orientations? 3 orientations. See, L value is 1. So M values are from minus 1 to plus 1, means minus 1 to plus 1. So minus 1, 0, plus 1. So total orientations, how many? 12 plus 1. So 2 into this 1. L value 1. Na? So 2 into 1 plus 1. So 2 into 1. 3 values. So 3 dabbas we will use. 3 orientations without this formula also you can say. Count this 1, 2, 3 values. Minus 1 to 0. So minus 1 to plus 1. How many values total? 3 values now. What are the M values? Minus 1, 0, plus 1. How many M values? 3. Difference understanding? What are the M values? Minus 1, 0, plus 1. How many values or number of orientations? How many means 3 orientations. Getting? And what we call them? Px, Py and Pz. So total there are 3 orientations. One is Px, one is Py, one is Pz. So why sir like that means? We cannot say. For P subshell, the orientations are in, one is in x-axis, one is in y-axis, one is in z-axis. So this is Px and this is Py and this is Pz. Electron orientation is like that in 3-dimensional manner. We cannot say. Okay. So P subshell consists of electron in 3 possible directions. One is Px, this is Px, and suppose this is Py and this is z-axis, then this is Pz. So total orientations, how many? For P subshell means 3 orientations. What are those? Px, Py and Pz. What are the M values for P subshell? Minus 1, 0, plus 1. Don't feel bored. These are very important. By using these only we will write electronic configuration, and by using these only we can come to know one particular atom can form how many bonds. So these are very important or not. So very simple. S means how many dabbas in our language? One dabba means one box. For P subshell there are three orientations. So three dabbas like that. Getting? Now odd numbers you know na? No need of formula now. So D means L value is 2. That means what are the M values? -2, -1, 0, +1 and +2. What are the M values for D subshell? Are you listening and following everyone? What are the M values for D subshell? Okay, D subshell means L value is 2. Okay, L value is 2 means M values are from -L to +L. So -2 to +2. So in between also we have to consider. So -2, -1, 0, +1, +2 like that. Then the total orientations 2 into 2 plus 1, then total 5 orientations. That means you will have 5 dabbas like this. D means. So how many? 1, 2, 3, 4, 5 dabbas. D subshell means. So we call them as so actually -2 to +2, -2, -1 and -2, -1, 0, +1, +2. Okay, what we represent like Px, Py, Pz, these 5 also we represent with different degenerating orbitals. One is dxy, dyz, dxz, dx square y square, and this one is dz square. dz square. Remember, of course, with these all shapes we will discuss. Shapes of atomic orbitals. Don't worry. What is dxy? No, my God, like that. No need to worry. Okay. Simply for D subshells, how many orientations? 5. That's it. What are those? dxy, dyz, dxz, dx square y square, and dz square. That's it. What is the meaning of dxy? We will learn soon. You have no need to worry. Getting what I'm saying? So these are about magnetic quantum number. Of course, if L is 3, you can say now it is from -3. L value 3 now for F subshell. So -3, -2, -1, 0, 1 and 2 like that. So total orientations are what? Means 2 into 3 plus 2. That means 7. So F subshell consists of 7 orientations. 1, 2, 3, 4, 5, 6, 7. 7 numbers you can count. 1, 2, 3, 4, 5, 6, 7. 7 boxes you represent. So these are called degenerating orbitals in F subshell. Understand? Subshells present in shell. In a shell, how many subshells? 0 to n-1. Now in a subshell, how many degenerating orbitals? Means these many, 2l plus 1. Understood? S subshell degenerating orbital 1. P subshell degenerating orbital 3, odd numbers. 1, 3, 5, 7 like that. Like dxy, dyz, F also have 7. We will discuss in shapes of atomic orbitals. You have no need to think about that right now. So what we discussed in magnetic quantum number, it represent what? Magnetic quantum number represent with M given about orientation of atomic orbitals. M takes the values from -L to +L. What are the M values? Means -L to +L. How many orientations or number of orientations means 2l plus 1. So those orientations I was explained here. So this is very, very important. Shell to subshell, subshell to degenerating orbitals we discussed. Okay. Next we have to discuss about one more quantum number, that is spin quantum number. Okay. So 3 quantum numbers completed actually now. How many quantum numbers completed? 3 quantum numbers completed. What are those? Principal quantum number, azimuthal quantum number and magnetic quantum number completed. Okay. So first one explained about orbit, second one explained about suborbit or subshell, azimuthal quantum number, And magnetic quantum number explained about degenerating orbital and its orientation. Orientation means direction. So last and final quantum number, that is spin quantum number, ms or simply s. Okay, spin quantum number, it is what? Represent with what? ms. Okay, suffix s or else simply s, spin quantum number. It was given by Uhlenbeck and Gaudsmith. Who was explained? Uhlenbeck and Gaudsmith was explained this spin quantum number. Spin quantum number explained about spin of electron. What it was explained? Spin of electron was explained, and spin angular momentum also was given. Spin angular momentum was given. Okay, it is square root of s into s plus 1 into h by 2 pi. This is spin only momentum we call. And one more, orbital angular momentum in magnetic quantum number I forgot to say. Orbital angular means subshell angular momentum otherwise. Orbital angular momentum. Orbital angular momentum, it is square root of L into L plus 1 into h by 2 pi. This is orbital angular momentum. What is L value? L takes the values, L is 0, 1, 2, 3, 4 and so on. S subshell, what is orbital angular momentum? Okay, S subshell, L value 0. L is 0, S subshell I told or not? So for S subshell, what is orbital angular momentum? Means square root of L into L plus 1 into h by 2 pi. Please remember. You remember orbit angular momentum? MVR is equal to NH by 2 pi. Yes, that is orbit angular momentum. This is orbital angular momentum, square root of L into L plus 1. What is L here? Azimuthal quantum number. So write down L values 0. 0 means what subshell? S subshell, P subshell, D subshell, F subshell. Do you remember? So L is 0, yes. L is 1, P subshell. L is 2, D subshell, like that. So for P subshell, what is the orbital angular momentum? They will ask you. You have no need to worry. So orbital, they only will give orbital square root of L into L plus 1. You have to use that set. Okay. And magnetic momentum, there is different formula. This is spin only momentum, like that was given. And now I'll explain about this spin quantum number. You please remember this orbital angular momentum. So magnetic momentum of electron, how to find also I'll explain. You have no need to worry about that. So what explained? Spin quantum number explained. Spin of electron was explained. Okay, that is different actually. This is no link with the spin quantum number. I forgot to say, that's why given. Okay, and S values are just plus or minus half. Plus or minus half S values. So what they explained, Uhlenbeck and Gaudsmith, what they explained means spin of electron in their own axis was explained. As they said, they means Uhlenbeck and Gaudsmith said like this: as Earth revolves in its own axis. Who revolves in its own axis? Earth revolves in its own axis. Like that, electron also revolves in its own axis, they said, in clockwise direction as well as anti-clockwise direction. I repeat, electron is revolving around the nucleus, I told you. That is correct. They are saying, yes, Earth revolving around the sun. Same way, electron revolving around the nucleus. At the same time, Earth revolves in its own axis. You know that. Like that, electron also revolves in its own axis, they said. So what they said? Electron revolves in its own axis. Electron revolves in its own axis as what? Earth revolves in its own axis. In what? In clockwise direction. In clockwise direction and anti-clockwise direction. Anti-clockwise direction. Who revolving? This point you must write, everyone. Electron revolves in its own axis. Okay, in clockwise direction. Clock means you have a clock, clockwise direction. So left to right, clockwise direction. Right to left, anti-clockwise direction. So what they said, electron is revolving around the nucleus in its own axis in clockwise direction as well as anti-clockwise direction as Earth revolves in its own axis. So if electron revolves in its own axis like this one and this is another. If electron revolves in, sir, this is own axis, sir, for electron. Understanding? So revolving clockwise. So left to right, clockwise. This is what? Electron revolution in clockwise direction. Electron revolving in clockwise direction. Here electron revolving in anti-clockwise direction. Electron revolving from left to right. This is what? Anti-clockwise direction. So for clockwise direction, the S value is plus half, and for anti-clockwise direction, S is minus half. You please remember these two. And one more important thing today I will tell you. Electron represent with half arrow. Electron represent with what? Half arrow. Clockwise direction electron, clockwise direction electron represent with half arrow upwards like this. Okay, so the most important thing. And anti-clockwise revolving electron represent with downwards like this or like this. So electron upwards, clockwise direction. Electron downwards, anti-clockwise direction. If a particular degenerating orbital has a single electron, we represent upwards only, clockwise direction. Remember this one. This point is very important. I told no. Suppose P3. P means how many degenerating orbitals? 3 degenerating orbitals. So individually, these 3 degenerating orbitals are all present in one particular direction. Don't worry. This we will understand in Hund's rule also. Hund's rule of speed, we will say Hund's rule like that. So 1, 2, 3 like that. Single electron represent. On pairing, you will use like this. After pairing only, electron we represent with downwards. Understanding? In same dabba means in one box or one degenerating orbital, 2 electron upwards, 2 electron downwards, we won't represent. We won't represent either upwards or else either downwards like this, wrong. This is wrong and this is wrong. Pairing means both are correct like this. That we will understand. Means no 2 electrons will be in same direction in a particular degenerating orbital. This is very, very important. So in a degenerating orbital, electron if paired, they must be one up, one down. So please remember, of course, we will discuss all these in Aufbau principle and Hund's rule and Pauli's exclusion principle, all those things. Okay. So this is about spin quantum number. Spin quantum number explained by Uhlenbeck and Goudsmit, and explained spin of electron in its own axis. Who was explained? Uhlenbeck and Goudsmit. Represent with what? MS or S. M takes the values, MS takes the values plus or minus half. I told only S. You can say MS or S. S or MS. MS or S. If electron revolves in clockwise, what is the spin quantum number value? Plus half. If electron revolves in anti-clockwise, what is the spin quantum number value? Minus half, like this. Okay, so this is about a spin quantum number. Electron revolves in clockwise direction, represent upwards. Electron revolves in downwards, that represent anti-clockwise, downwards. Okay, so this is about what? Spin quantum number. So very important for us. So we discussed about all 4 quantum numbers, correct? So next we will discuss 4 set of quantum numbers for a particular electron is correct or wrong. Okay, and one more thing I forgot. For a particular, suppose for a particular subshell, suppose D subshell is there, D subshell given, D subshell has maximum how many electrons? Do you remember? 10 electrons. How I told? 4L plus 2. Otherwise add 4 I told now. 2 plus 4 6, 6 plus 4 10. So D subshell has maximum 10 electrons. Among them half has half electrons. Half electrons has plus half spin and half electrons has minus half spin. This is very important. Among 10 electrons, how many are in clockwise direction? How many are in anti-clockwise direction? Means 5 electrons are in clockwise direction and 5 electrons are in anti-clockwise direction. Suppose F subshell has how many? 14 electrons. Do you remember? Sir, S2, P6, D10, F14 electrons present. I told or not? So, in a particular subshell, half electrons have plus half spin, half electrons have minus half spin. This is very important. Okay, so these are very important for us. So F subshell has 14 electrons. So how many electrons have plus half spin? How many electrons have minus half spin? Means 7 electrons with plus half spin and 7 electrons with minus half spin. These are very important. Okay. Now I will give you one question. See, following set of 4 quantum numbers, 4 quantum numbers are correct. Okay, means which of the following set of 4 quantum numbers are correct? Okay, that I am asking. N is equals to 4, L is equals to 3, this L is equals to 3 and M is equal to minus 2 and MS is equal to either plus of or MS can be either plus of or minus of. Whether plus of or minus of, now we cannot say. If I written either plus of or minus of, correct. Apart from anything like 1, 2, 3 or minus 1 like that, if I written instead of for MS, that is wrong. Instead of plus of or minus of. Getting what I am saying? MS is always either minus of or plus half. That's it. Got it clearly? Okay. Now these 4 set quantum numbers are correct or wrong? Means I will say yes, this is correct. Why this is correct? N is 4. L values are from 0 to n minus 1. I told 0 to n minus 1. So this is also correct. So 0 to 4 minus 1. Any of L value is correct. Means how many exist means 0 to 3 exist. But n is 4, L is 3 I given. Correct? So n is 4, L is 3. That means what is the meaning? Yes, exist because L values are from 0 to 4 minus 1. Okay, L is 3, correct. L is 3. So M values are from minus L to plus L. L value is 3. So what are the m values? -3, -2, -1, 0, +1, +2. I was given -2 here. So m also correct. Any one of these value if given, correct. Existing how many units? -3 to +2. Understand? So like that we have to consider. So actually n is 4, L is 3. Okay, it is 4, L is 3. Sir, it is 4f I can say. How I said 4f? I told no. N is equals to 1. Sorry, not n. L is equals to 0. I have no need to write. But L is 0, S subshell. L equals to 1, P subshell. L equals to 2, D subshell. Like that. L is 3, F subshell. L is 3, F subshell. Fourth shell, so 4f. Understanding? All these correct or not? Yes, correct. Next, second one, only two I will give you now. N is equals to 4, L is equals to 4, M is equals to -3, MS is equals to either minus or given. These four quantum numbers for a particular electron, correct or wrong means wrong. N is 4, L is 4, both can never be same because L values are from 0 to 4 minus 1 only, but L value 4 I was taken. So N is 4, L is 4, never be exist means never exist. So this second set of 4 quantum numbers are wrong and first 4 quantum numbers are correct. Understanding? So these are for particular electron actually. Okay. So N value 4, L value is 3 correct, M value -2 correct. Suppose if I given M values is -4, wrong this is. Because L is 3, so the M values are from -3 to +3 only. -3 to +3 only. But here if I given -4, this also correct. This set of 4 quantum numbers also wrong. Why? Because I given 4. So 4 is wrong. So -3 if I given, -2 if I given, correct. Now these 4 quantum numbers are correct. If I given -4, wrong. Why wrong? L is 3. So M values are from -3 to +3. In between -3 to +3 only correct. If I written -3, correct again. Okay. Few more examples I will give for quantum numbers. Don't worry. Many examples and Aufbau principle, Pauli's exclusion principle, Hund's rule, everything we will discuss in our next class so that you will get full clarity. So please revise all these 4 quantum numbers. Very, very important. If you don't know this, you cannot write electronic configurations properly. So if you have any doubts, don't feel bad about that. They don't know, like that. You can learn. You have to learn. I have to explain. So if you have any doubts, please ask me. I'll explain. Pakka.